Alright, sorry I was having some technical difficulty on that. My second video crashed on me. So, I had to, I also lost my StatCrunch page, so I had to go back and get my expected values from the previous recording, and I got it. So now I think we are ready to go. We are ready to take a look at, let's see here. So I went back and I looked at the second video and I looked at the expectant frequencies and I rounded to the nearest whole number, the nearest integer, and I got them, and luckily they were right. There's a lot of places to make a mistake there. Luckily no mistake was made. So I got the observed value. There we go. I got the observed values. That's on the frequencies. And I got the expected values. That's right here. Alright, so next what they want us to do is they want us to find the critical value. That's kind of like the borderline for the chi-square. And what we need to do there is we need to get the chi-square critical value table, and it is going to depend on the degrees of freedom, and the degrees of freedom ask us how many categories are there minus 1. So let's see how many categories we got. We got 1, 2, 3, 4, 5 categories, 5 class boundaries. 5 minus 1 is 4, so our degrees of freedom are 4. And then we also need our alpha value. So let's dig up what our alpha value is. Our alpha value is 0.01. So let's see if that has that. 0.01, a degree of freedom of 4. So that's going to be 13.28. Let's see what they wanted that rounded to. 3 decimal places. Uh-oh. So we might need something a little bit more specific. Let's just look at one of these. Hopefully these will give us something a little bit better. 4 degrees of freedom. There we go. 4 degrees of freedom. Alpha value 0.01. 13.277. Okay. 13.277 is the critical value. 13.277 should be the critical value. Okay. That was just from the table. I just Google searched that. Okay, Google searched the table. 4 degrees of freedom, alpha value 0.01. Alpha value is given. Degrees of freedom is the number of categories minus 1. 1, 2, 3, 4, 5. 5 categories. 5 minus 1 is 4. So 4 degrees of freedom, alpha value 0.01. I Googled that and got a critical value. That's the borderline of 13.227. So when are we going to reject the null hypothesis? Is any time we are greater than this critical value. So any time this chi-square is greater than, I think it's going to be strictly greater than 13.227. Alright, let's see. Okay. Remember, we reject the null hypothesis when we have an extreme value. That means it's very far away from what we expect. So how far away is very far away? When it's further than 13.227 chi-squares. Okay, so what is the chi-square test statistic? Not the borderline, but the actual test statistic? Well, I think we can find that on StatCrunch. Let's do it. We have our observed values and our expected values. So I will write down my expected values, or maybe just memorize them. I wonder if I might have to go back and forth, but I think that we can get this in StatCrunch here. Back in StatCrunch, I lost my other StatCrunch table. All right. There's the observed values. We have the expected values, they were very hard to get. The expected values are, I'm going to move this over here. Let's see if I can move this down here. Maybe all the way down. 1763, 79. 1763, 79. 1763, 79. 34 and 5. 34 and 5. Okay. And now we should be able to get a goodness of fit test. So we can go to stat, goodness of fit. This is a chi-square goodness of fit. The observed column, that's the frequency. The expected, it's going to be under the expected values column. And now we should be able to get a chi-square statistic. Chi-square statistic is 0.481, so on and so forth. So I'll go ahead and copy that in case I need it. I don't know how many decimal places, but I'll just copy that. That tells me that that's not very unusual. Round to 3 decimal places. So it needs to be a 2 there. Should be good. Okay, great. Remember, we reject the null hypothesis if it was greater than our critical value. That is not greater than our critical value, so we do not reject the null hypothesis. We fail to reject the null hypothesis. So what does that mean? At the 1% significance level, remember what the null hypothesis was? You got to go back and read it. But the null hypothesis said that it is a normal distribution, and we failed to reject it. We did not reject it. We embraced the null hypothesis. The null hypothesis said that it was a normal distribution. At the 1% significance level, there is or is not, which one? Enough evidence to reject the claim. We do not reject the claim. Remember, fail to reject. There is not enough evidence to reject the claim that scores are normally distributed. And that is the end of it. So sorry that took 3 videos, but we got it done.